Are you fond of watching or playing volleyball? When the announcer says that the team is gaining momentum, it means that the team is on the move and is going to take some effort to stop. When momentum is present on the side of your net, you can feel it. Your team is in the flow. Energy is high, passing is effortless, a transition is fluid, and points come easily. Hello students! Welcome to Science Matters, where learning never stops. We are now in Quarter 4, Week 3. In this lesson, we are going to learn about momentum and impulse. Our most essential learning competency for today is to relate impulse and momentum to collision of objects. For example, vehicular collision. All objects in motion have momentum. So, what is momentum? Momentum is the measure of one's motion. The amount of momentum depends upon the two variables. How much the object is moving refers to its mass, and how fast the object is moving, which is the velocity. So, it is important to remember that there is momentum when the object has mass and the object is moving. Momentum simply means mass in motion. It is the product of mass and velocity, mathematically expressed as P equals m times v, where P is momentum, m is mass, and v is velocity. The unit of mass is kilogram. For velocity, the unit is meter per second. Therefore, the unit for momentum is kilogram meter per second. Imagine a bus and a car moving at the same speed. Which vehicle do you think will be hard to stop? A bus or a car? Why? If your answer is bus, then you are correct. The bus is more massive than the car. The greater the mass of a moving object, the greater the momentum. And the greater the momentum, the harder it is to stop the object in motion. Let us have another example. For cars of the same masses but are moving with different velocity, which do you think has more momentum and which is difficult to stop? For moving objects with the same masses, the faster object has greater momentum. Therefore, it is hard to stop. The concept of momentum helps us to understand the tendency of moving objects to stop. These are the concepts you need to remember. The faster the object is moving, the greater the momentum. The greater the mass of an object, the greater the momentum. The greater the momentum, the harder the object to change motion or to stop. Here are some daily life examples of momentum. A truck full of logs has a large mass and must slow down long before the stoplight because it has a large momentum and is difficult to stop. A bullet, although small in mass, has a large momentum because of an extremely large velocity. Let us now have a sample problem. Consider a cargo truck with a mass of 10,000 kilogram traveling at a velocity of 40 km per hour. What is its momentum? Let us have the solution. The given mass is 10,000 kilogram and the velocity is 40 km per hour. We're gonna look for the value of momentum. The equation for momentum is P equals m times v. For the solution, substitute the value of mass and velocity. So, we have P equals 10,000 kilogram, which is the mass, multiplied by 40 km per hour, which is the velocity. Then, the momentum of the cargo truck is 400,000 kilometer per hour. Another example is a small car with a mass of 2,000 kilogram traveling at 40 km per hour. What is its momentum? Now, let us solve the problem. The given mass is 2,000 kilogram and its velocity is 40 km per hour. Let's find out the value of momentum. Again, the equation for momentum is P equals m times v. Let us substitute the value of mass and velocity. So, we have P equals 2,000 kilogram, which is the mass, multiplied by 40 km per hour, which is the value of velocity. Then, the momentum of the cargo truck is 80,000 kilometer per hour. If both the cargo truck and car traveling at the same velocities lose their brakes and crash against the brick wall, which do you think would be more damaging? Is it the cargo truck or the car? If your answer is the cargo truck, then you are correct. Although the two vehicles have the same velocities, they have different masses. The impact of the truck's collision with the brick wall is far more damaging compared with the impact of the car's collision with the brick wall. As we learned earlier, any object with momentum is going to be hard to stop. The more momentum that an object has, the harder it is to stop. And to stop such an object, it is necessary to apply a force against its motion for a given period. As the force acts upon an object, the object's velocity is changed. Hence, the momentum is changed. If the force acts opposite the object's motion, it slows the object down. If the force acts in the same direction as the object's motion, then the force speeds the object up. Force will change the velocity of an object. If the velocity of the object is changed, then the momentum of the object is changed. The change in momentum is called impulse. The impulse experienced by the object equals the change in momentum of the object. In equation form, force times the time equals mass times change in velocity. In physics, the quantity for force times time is known as impulse. I is the symbol for impulse. Mass times change in velocity is known as a change in momentum. Therefore, impulse equals the change in momentum. The unit for impulse is kilogram meter per second or Newton second. Let us now relate impulse to momentum. When someone is driving a car with a higher mass and a higher velocity, it gives the car a higher momentum. We know that the higher the momentum an object has, the more difficult it is to stop. Therefore, when someone suddenly crosses the road while you are driving at a higher velocity, it would require you to apply greater force on the brake, or it takes you a long time to slow down and bring it to a stop. The impact force of a fast-moving car is higher, and therefore it can cause greater damage after the collision than the car moving at a lower velocity. If the change in momentum occurs over a short time, the force of impact is large. If the change in momentum occurs over a long time, the force of impact is small. Impulse or the changes in momentum happen every time. A fast-moving car that suddenly stops might have damaging effects not only on the vehicle but also on the person riding on it. Various devices have been installed in vehicles to ensure the safety of the passengers. That's why, when we travel, it is important to put on the seatbelt, so that when the car suddenly stops, this seatbelt will help the body slow down. It also protects your brain and spinal cord. And in case of an accident, it spreads out the force of collision. The use of seatbelt is even required by the law to lessen injuries from car crashes. Another interesting example of impulse in everyday life is the car airbag system. Airbags are also installed in most cars, aimed to increase the time of impact between the driver or passenger and the crashing vehicle in an event of an accident. The airbag increases the time required to stop the momentum of the passenger or driver. Having padded floors at a gymnasium is another application of the concept of impulse, to reduce the force of impact when someone lands on the floor. The padding increases the time between the person and the floor. Just like the airbags, when the contact time increases, the impact force decreases. That's all for now. I hope you understand what is impulse and its relationship with momentum. I hope you learned something new today. This is Ma'am Annabel Piring Hermosa, your grade 9 science teacher, inviting you to like, subscribe, and share Dasma North Science so you won't miss any video lesson. See you again next time, only here at Science Matters, where learning never stops.